How does a modern aircraft, flown by an experienced crew, simply fly and crash into the side of a mountain? That was the question investigators were faced when it came down to understanding the details of how Air Inter Flight 148 unfolded. And as it turns out, a combination of a complicated approach, cockpit stress, the way that certain information on the flight deck was represented, and an unfortunate coincidence all came together in a deadly combination that spelled disaster. So, let's back up. What exactly went wrong here? Well, come with me, my viewer. Together, we'll delve into the story of Air Inter Flight 148. But first, let me tell you about today's sponsor. Here at Disaster Breakdown, I do my best to be transparent about where information comes from for the content we cover on this channel. In the current age of the internet, that's become increasingly difficult, with the amount of misinformation we experience, especially on social media. So if you're concerned about the current state of information like I am, allow me to introduce you to this video's sponsor, Ground News. Ground News is the news aggregator app that puts context at the forefront of any story. Related articles on a topic are all brought into one place, where you, as the reader, can easily compare coverage and analyze insight into the reporting practices of each news source, including who really owns each platform and their political leanings. One of my favorite features is the timeline. This lets you see who broke a story first and who chimed in next, and how the narratives unfolded afterwards. I find this very interesting. Take, for example, the coverage of this airplane accident in Nepal. We can see there was actually quite a range of coverage from different outlets, and Ground News breaks down the factuality of each outlet reporting on it, so I can quickly sort through to more reliable sources if I so choose. Ground News really shines because they do this for everything. They even highlight blind spots, news stories where you can discover stories that are disproportionately covered by one side, which for someone like me, it's important to know who is shaping the narratives around issues that affect me. Ground News has really helped me stay informed recently. So why not try it out for yourself? Go to ground.news/breakdown and try it out today. If you sign up through my link, you'll get 40% off the Vantage plan, which gets me unlimited access to all features. I think Ground News is doing important work in making the news landscape a better place, and I hope you'll check them out. Thank you to Ground News for sponsoring this video. It's 6:30 in the evening on January 20th, 1992. Air Inter Flight 148 has just departed Lyon in France for a short domestic flight northeast to the city of Strasbourg. The plane soars high over the French countryside, with 96 people on board the aircraft that evening, and it was only supposed to be a short flight of less than 1 hour. Air Inter, in their time, operated a large network of domestic flights within France, directly competing with the TGV intercity trains, the airline often operating out of the larger cities, connecting them with regional airports. Lyon to Strasbourg was one of those. The official call sign for this flight, in full, was Air Inter 148 Delta Alpha, which was abbreviated to simply Delta Alpha in ATC communications. This is something that will come up when we look at the cockpit voice recording later. Up on the flight deck, commanding the plane was 42-year-old Captain Christian Hecke and 37-year-old First Officer Joel Sheraban. Both pilots were highly experienced in their own right. Captain Hecke, with nearly 9,000 total flight hours, had previous experience flying a multitude of different aircraft for Air Inter, such as the Airbus A300 for example. Meanwhile, First Officer Sheraban, with 3,600 flight hours to his name, had only joined the airline 2 years previously. The First Officer's previous flight experience at the airline is quite interesting, as before he transferred to the aircraft we are going to talk about in just a minute, he previously flew the Dassault Mercure, a failed French airliner that only Air Inter ever operated, and thus very few pilots ever got to fly. So, despite the great experience of both pilots, neither of them were all that experienced on the plane they were flying that evening, the Airbus A320. Air Inter had the then new A320 in their fleet for a few years at that point. However, the two pilots that night had less than 250 hours on the type between them. The captain with 162 hours, and the first officer with just 61 hours. Both of them had only completed their training on the aircraft in the previous months, and there was no requirement for the airline to pair either of them with a more experienced A320 pilot. The Airbus A320, when it arrived on the aviation scene, was in a class of its own. The plane boasted impressive new technology with a full glass cockpit and a fly-by-wire control system. It was highly computerized in a departure from the more analog and mechanical flight decks the pilots would have been familiar with. Last year, we discussed the inner workings of the A320 and its fly-by-wire system in a separate video, if that is something you wish to learn more about. Okay, I need to just interject with something really quick. Hi, this is Future Chloe talking from the editing office. I have to mention this somewhere or I'll get a ton of comments about it. In the simulated reconstruction, I have used an A320neo model, in lieu of the actual model of the accident flight, which was the A320-100. The main reason for this is there is no 100 model in any flight sim to my knowledge, and the contemporary livery was readily available for this model, so we've just kind of went with it. It's okay, we'll get through this together. The A320, like every plane of this new generation, features a comprehensive flight computer where pilots can input a route for the plane to follow. Before departure from Lyon, they would have keyed in the whole route to Strasbourg, and they could even input the approach and landing runway. All of this information would then be displayed on the navigation display, which effectively functions as a map. This would be a good time to take a closer look at the airport in Strasbourg, as the airport itself plays a rather interesting role in how everything that follows unfolded. Strasbourg, in France, is located here, near the border with Germany. The Strasbourg airport is located to the southwest of the city and features just one runway with a northeast-southwest orientation. The runway is marked 0523, and the runway numbering was the same in 1992 as it is today. Let's take a moment to appreciate that further to the southwest of the airport is a small mountain range, which includes the peak of Mont Saint-Odile. This mountain would ultimately become the crash site of Flight 148. As to how the plane ended up here instead of at the runway requires a deeper understanding of the airport. Because of these mountains, there is limited assistance for approaches to runway 05, the approach from the southwest over the mountains. The reciprocal side was complete with full instrument landing system, or ILS for short. The ILS works by broadcasting a radio signal out into the flight path. Pilots can then tune into the same frequency on their radio sets, which can be used to guide the plane laterally and vertically with assistance from the glide slope to the foot of the runway. It's a great tool in limited visibility, for example, and can lower a pilot's workload. Runway 05 did not have an ILS at the time. Instrument capabilities for the runway were subject to testing, which found that a steeper approach gradient would be required, instead recommending the use of a non-precision approach for runway 05, and to help with this, VOR equipment was present, located a few miles from the airport, directly under the flight path. Very high-frequency omnidirectional range is a ground-based navigational aid that provides pilots with lateral guidance. Using the right inbound course facing the runway, pilots can still be guided to the airport. However, unlike the ILS, as is the case on runway 23, there is no glide slope or any sort of altitude guidance. Pilots would have to consult their approach charts and calculate some sort of descent path, and this can drastically increase their workload. As you then might expect, runway 23 is usually favored, and was what the pilots of Flight 148 were originally anticipating. However, there were good reasons to use a runway 05 approach, despite the faff that comes with it. On that evening, winds were blowing from the northeast, meaning that for favourable headwinds on landing, approaching aircraft should use runway 05. Sure enough, this was the runway in use on the night of the accident. At just before 7 PM local time, the first officer tuned into the Strasbourg airport ATIS, which continuously broadcast recorded weather. It was here where they discovered the wind situation, which would change their approach plans. The first officer even commented to the captain, "Wind from 050, 18 knots. Unlucky. Investigators assumed that at the onset of this news, the first officer then proceeded to change the approach plan in the flight computer, from ILS 23 to VOR 05. Now would be a good time to mention that though both pilots had flown into Strasbourg numerous times, this was actually the first time that either of them had to perform a non-precision approach for runway 05 in the A320. Because they were so new to the plane, all other times they had performed it, it was in aircraft they were more accustomed to. Looking over the cockpit voice recorder transcript, it's clear that Captain Heke was apprehensive about the non-precision approach for 05. He already was trying to navigate a tight schedule that evening and was now facing a mounting workload. What followed on the flight deck was a discussion about the approach between the two pilots. First Officer Sharaban was a rather forward-thinking pilot who often challenged the captains he flew with. He suggested the straight-in approach, non-precision using the VOR equipment. The apprehensive captain instead insisted on still using the ILS for runway 23, but then performing a circle-to-land procedure. Whilst the first officer was confused by this, even going on to say, "I don't know why you don't want to try VOR runway 05, I feel it is important to at least remember that what the captain was suggesting is still a valid strat. There is nothing unsafe about this sort of approach." The captain decided to override the first officer's suggestion, and we do actually have some insight as to why he might have done this. The captain gave his reasoning, which we can see in the transcript. He believed that they would have to circle anyway to burn off excess speed and altitude, which he believed could add an extra 10 minutes to their flying time. At just after 7 p.m, the pilots were in communication with the Strasbourg approach controller, who cleared Flight 148 to fly directly to a key waypoint known as Andelot. Andelot is an arbitrary waypoint that is roughly 13 miles from the airport on the extended runway center line. Andelot is part of the VOR procedure for runway 05. However, Captain Heke still wants to approach ILS 23 with a circle to 05. His frustration was picked up on the cockpit voice recording. He exclaimed, "Andelot, now they're starting to mess me about." He would also relay this frustration to ATC. "We are not going to mess about descending like that," he speaks. Approach Control does try to compromise with the captain, and offers radar guidance to perform a pattern to the southwest of the airport. They clear Flight 148 to Andelot at 5,000 feet, but to get there, the A320 will perform two 180 turns, which would bring the plane over the range of mountains southwest of the airport. There were other planes in the region, especially departing aircraft from Strasbourg, and this was something the controller needed to keep in mind. The approach controller was not expecting Flight 148 to perform this sort of approach. He was expecting the flight, similarly to the first officer, to perform a straight-in, non-precision VOR for 05. Regardless, with this compromise, the controller cleared the plane to descend, and the pilots began to execute this procedure. Flight 148 had substantial altitude as it entered the pattern at over 9,000 feet. As Captain Heke had intended to use ILS 23, the higher altitude of the aircraft reflected that. They needed to lose the excess altitude, as usually aircraft reach the Andelot waypoint at 5,000, so the captain began to calculate a new descent path, so they would reach this new altitude to then join the final approach path when they come back around to Andelot. Remember, they don't have altitude guidance, so any descent profile needed to be manually input by the pilots. Sure enough, the crew calculated a new descent path with a negative 3.3 degree flight path angle, so descending 3.3 degrees nose down. The captain then leaned over to the autopilot panel and attempted to input that into the autopilot. And it was here where things really fell apart. You can say whatever you want about the choice of approach or any of the other circumstantial aspects of the flight, but what happened here was not good. And to understand why that is, let's go to the A320's autopilot panel. It is officially known as the FCU, or Flight Control Unit. This is where the pilots effectively tell the autopilot what to do. In the center of the unit are the main autopilot and autothrottle master switches. However, looking at the unit more closely, you'll notice a number of different digital display windows with associated knobs and switches. From left to right, we have airspeed, heading, altitude, and vertical speed. In this case, it is the vertical speed window that is our focus. First of all, what do we mean by vertical speed? Basically, it's how quickly the aircraft will climb or descend. As feet is the standard unit of altitude in aviation, vertical speed is therefore usually measured in feet per minute. On the A320, Airbus designed this window to show a positive or negative symbol in addition to the value selected. So, for example, selecting a climb rate of 2,000 feet per minute would look like this, and a descent of 1,500 feet per minute would look like this. Now, if we take a gander over to the center of the FCU panel again, we can find a vertical speed to flight path angle toggle switch. You see, the display window for the vertical speed is actually shared with the flight path angle selection. The switch changes the mode from vertical speed to flight path angle. So then, you would expect that because the pilots had calculated a flight path angle of 3.3 degrees, they would switch to this mode and select negative 3.3. However, there was a deeper problem here. Remember when I just showed you how the vertical speed was displayed? Well, that is how it looks today in a modern A320 display. It now looks like this because of this accident. In the A320-100, that is what this plane is, when it was first launched, Airbus designed the vertical speed display to be abbreviated. So the two examples I showed just before would have actually looked something like this in an early A320. You'll notice it looks very similar to the flight path angle display. The indication for which mode was active was very small. What ended up happening was, in the stress of trying to get this aircraft on the ground, they tried to input a flight path angle when the plane was actually still in vertical speed mode. They selected negative 3.3, thinking that meant 3.3 degrees down, when in reality they had just selected a descent rate of 3,300 feet per minute, which is far greater than any normal descent rate. With the autopilot engaged, the plane sought to execute this instruction, and the plane's nose drops, and within about 1 minute, the plane's wreckage would be laying on the mountainside of Monsanto Deal. Now, we need to talk just a little bit about the A320 and its fly-by-wire nature for just a moment. In a simple sense, fly-by-wire means that flight control inputs, either made by the pilot or the autopilot, are fed electronically to a series of computers on the aircraft, which then activate the hydraulic systems that move the ailerons, elevators, rudder, and so on. Because of this computerized nature, Airbus was able to install a number of protection systems, and the fly-by-wire operates the plane within a safe boundary. This is supposed to prevent the plane from entering excessive descents, for example, in normal flight. However, in an unfortunate coincidence, it was later discovered by investigators that a turbulence effect around the same time of the final descent had jostled the aircraft in a way that the onboard computers had interpreted the inputs of the pilots as an emergency action, allowing the plane to go beyond its safe limits, and therefore, this excessive descent went ahead unchecked. In the minutes before the crash, Flight 148 was flying away from the airport and was about to begin its next turn towards the Andlo waypoint. In this particular case of a plane crash, we actually have a cockpit voice recording available to work with. The fragment of the recording we have is roughly the final 3 minutes or so of the flight, so from around this final turn to impact. You'll hear on the recording, to assist them in the final turn, the controller gets on frequency to issue them with heading instructions.
Continue autorisé le virage sur Épinal vers le niveau 140. À gauche Épinal, niveau 140, à gauche kilo. Bien, vous rentrez le 70 libéré à l'intérieur, et 3 kilo. D'accord. On reprend à terre 15 jours, après je peux prendre la réserve. Oui, avec le moment, ça n'est pas en fait. Ok. Poursuivez le virage à gauche, pour vous établir sur le 051, vous êtes à 400 nautiques dans l'eau. On parle à gauche en eau. One to 04, take off, you take off wind 0424 knots, maintain runway heading after. Yeah, that's 1 for 7 type of runway heading. Arnold avec le pour le décollage à niveau maintenu. Le décollage, ça ira avec le vélo.
Intérieur là.
In the turn itself, they undershot it, and were now off course, skewed from their navigation towards Andlo. The first officer noticed this. The approach controller also noticed this and then also gave a confusing readout of Flight 148's position relative to Andlo. Effectively, attention on the flight deck was shifted from the vertical situation to the horizontal situation, all the while the aircraft is descending rapidly, and because the crew had shifted focus away from their altitude, they were unaware they were rapidly approaching the terrain below. Let's talk about CFIT. That's Controlled Flight into Terrain. This is a rather broad term that defines a category of aviation accident where a plane is, well, controlled into terrain for whatever reason. AirInter 148 is, of course, one of those, but after decades of advancements in aviation throughout the 20th century, a number of systems had been developed to act as lines of defense against CFIT scenarios. Like, Flight 148 was far from the first case of something like this. Now, one of those systems is the Ground Proximity Warning System, GPWS, a radar device that detects how high an aircraft is above the ground. If it senses it is dangerously close to the ground in an emergency scenario, it will audibly alert the flight crew. Depending on the aircraft, it could sound something like this.
Terrain ahead. Pull up!
In a stunning revelation to investigators, this particular A320 did not have a GPWS installed. Supposedly the reason being that nuisance alerts were known to occur, and at the time, it wasn't really required. It wasn't on the minimum equipment list. So, Flight 148 continued descending into the mountains. The region was shrouded in cloud with nothing to see through the pilot windows. Whether or not the pilots saw the mountain they were about to hit in the final moments before impact, that is difficult to say. However, the analysis in the investigative report mentions how investigators believe there was no intervention from either of the pilots at any point. The Airbus side sticks remained in neutral, and the throttle stayed in the auto position. The cockpit voice recording gives us a small window into that critical short space of time, the final milliseconds before impact. We are now going to play that final part of the recording. What you will hear is the radio altimeter call out 200 feet. Much like the GPWS, the radio altimeter measures height above the ground. However, in this case, it could not warn the pilots in advance. The minuscule time difference between the 200 feet call-out and the end of the recording would seem to indicate the plane's rapid descent. Let's go to the map again. AirInter Flight 148 made its impact on Monsanto Deal, highlighted here. As the plane was mid-bank, the left wing struck the mountainside first, carving its way through the trees and terrain. When the nose of the aircraft impacted, both of the pilots were believed to have been killed instantly. Over the following seconds, the rest of the fuselage shattered, with parts of the wreckage erupting into flames. Of the 96 people on board the aircraft, 85 perished in the crash itself, leaving 11 total survivors. Most of those surviving passengers were sitting in a small section of the cabin towards the rear of the plane, that had remained relatively intact, all things considered. The crash here left a scene of total devastation. Twisted metal and torn up fragments of an A320 were interwoven throughout the landscape. Looking at some of these post-crash images, it's hard to believe anyone could have survived such an accident. And for the survivors on that evening, surviving the plane crash was only the beginning of the ordeal. No one really knew where the plane had actually crashed, despite it coming down near the city of Strasbourg. There were no ground witnesses to the accident and radar data was sketchy. The few surviving passengers escaped the wreckage and congregated around a burning section of the plane. It was also the middle of winter and these survivors had to endure harsh winter conditions. So there they waited by the wreckage for the arrival of rescuers, which they assumed would have been in a matter of minutes. But half an hour quickly turned into 45 minutes, then 1 hour with still no sign of help. 1 hour then turned into 2, and rescuers still had no idea where the plane was. A smaller group of survivors took it upon themselves to venture into the woods for help. One notable passenger, one Nicholas Scurius, perhaps incredibly stumbled across a media team whilst looking for help, and this was how the plane was eventually found. A small news team was brought back up to the crash site, where the injured survivors could finally be rescued. Unfortunately, 2 of the survivors of the initial crash sadly died soon after, which brought the death toll to 87. The investigation into the crash was difficult, and not without its fair share of problems. The flight data recorder was destroyed in the accident, leaving its data unrecoverable, instead leaving investigators with the quick access recorder for basic flight data. However, when the investigation into the accident concluded, investigators made dozens of safety recommendations going forward, not least of which was an initiative to redesign the vertical speed and flight path angle display. Investigators discovered that numerous crews, including similar cases at Air Inter, where pilots had confused the shared display window. Investigators also called for an overhaul in flight crew training on the new A320 and established the necessary procedures so that rapid descents like this can be more easily identified. The inexperience of the 2 pilots on this aircraft was also brought up. Air Inter had paired 2 pilots with little experience on the aircraft together, the investigation recommending that any new crew members should be paired with a more experienced member of crew. French air safety regulations at the time did not encourage this. This was especially highlighted given the massive jump between the Dassault Mercure, for example, with its old 1970s analog cockpit, and the modern A320 with its glass cockpit. Shortly after the accident, investigators recommended that French authorities amend the regulations around the ground proximity warning system. The fact that it was not technically required, and the fact that this accident occurred at all, exposed a huge safety risk. The GPWS is there to prevent the exact kind of accident that occurred on that night. If it was there and was able to do its job, it could have given the pilots the necessary time window to act. Instead, they got no warning, and at night, inside the dark winter clouds, they could not have seen that they were flying straight towards a mountain. You heard on the cockpit voice recording, you heard there was no time to even verbally react, and we don't even know if the pilots ever saw the thing before they crashed. Other areas of safety recommendations related to air traffic control communication and the state of the flight recorders. But in conclusion, the crash of Air Inter Flight 148 was put down to a multitude of causes, an amalgamation of errors and coincidences all combined together and worked against the crew that night. The lessons learned from this tragedy have been brought forward into pilot training. The accident can be used as a case study in the areas of crew resource management and high workload environments. Continuous efforts in the areas of technology and pilot training have meant that accidents like these are exceedingly rare today. Hello everyone, thank you so much for watching this video. If you enjoyed it, be sure to drop a like and subscribe so that you don't miss out on the next episode. I am currently in the process of beginning production of the next big project that I'd like to work on, which will encompass the icing related problems with the Fokker 28 and related aircraft. It's a video I have wanted to do for a long time and I would like to finally get around to it. It is going to be a very big video like the 737 MAX one, so possibly, feature length like that one was. I love making those types of videos and would really love to make more of them for you to watch. Anyway, it is that time where I must take a moment to thank my amazing patrons over on Patreon for their incredible support to the channel. Their names are scrolling on the screen right now, so if you see your name here, a massive thanks to you. We have a whole bunch of new shoutouts to get through today. I have to say that a lot of you pledged since the last upload, and I am eternally grateful for that. Thank you so much. So, beginning with the business class tier patrons in order of which they joined, shout out to Kozmistia Sasha, Skippy, Sarah Marie, Kim Roger, Helen Gibson, Claire Robinson, and Harris Brody. Thank you all so very much. And a big thanks goes out to my first class tier patrons in order of which they joined. A thank you to Daniel Wagner, Fluffy Whiskers, Alexander Baridan, and Andrew P. Thank you all so very much. Legends. Total legends. If you would like to support the channel further and even get your name featured here at the end of the next video, you can always join the Disaster Breakdown Patreon from just £1 per month, and the link to that will be in the pinned comment and the description below. That is all from me today, and I'm going to shut up now. Thank you all so much for watching, have a lovely day, and I will see you next time. Goodbye!